This lesson shows how to solve inequalities. You solve inequalities in much the same way as equations, with the properties of inequality, which say, if you perform the same operation on both sides of the inequality, it remains true most of the time. For example, if you start with the true statement 2 is less than 4 and add 1 to both sides, you get 3 is less than 5, which is still true. On the right, if you start with the statement 5 is greater than 2 and subtract 3 from both sides, you get 2 is greater than negative 1, which is still true. There are similar properties for multiplication and division. On the left, if you start with the statement 4 is less than 6 and multiply each side by 2, you get 8 is less than 12, which is still true. On the right, if you start with the statement 8 is greater than negative 4 and divide both sides by 2, you get 4 is greater than negative 2, which is still true. However, there are differences between the properties of equality and inequality. If you start with the true statement 4 is less than 6 and multiply both sides by negative 2, the new statement is negative 8 is less than negative 12, which is not a true statement. Look at the number line. Negative 8 is to the right of negative 12. So negative 8 is greater than negative 12. So you can see when you multiply an inequality by a negative number, you have to switch the direction of the inequality in order to have a true statement. The same is true of division. If you start with the statement negative 8 is less than 12 and divide both sides by negative 2, you get 4 is less than negative 6, which is not true. You have to switch the direction of the inequality for the statement to be true. The general strategy for solving an inequality is the same as with an equation. You add, subtract, multiply, and divide on both sides to isolate the variable and find a solution. In this example, begin by subtracting 5 from both sides, giving 3x less than 21. Then divide both sides by 3 for the solution x less than 7. It's a good idea to graph the solution to the inequality. Draw an open dot at x equals 7, the boundary of the solution, and shade the number line to the left, which indicates all numbers less than 7. Unlike an equation, an inequality has two checks. The first is a boundary check. Begin by rewriting the inequality as an equation. Then substitute the boundary of the solution, x equals 7, into the equation. This gives 3 times 7 plus 5, which is 21 plus 5, which is 26. And the boundary value checks. The boundary check verifies that you subtracted and divided correctly when you solved the inequality. The second check is an inequality check. Select any convenient value in the solution set, that is, any convenient value less than 7, like x equals 5. Then substitute x equals 5 into the inequality and simplify. 3 times 5 plus 5 is 15 plus 5, which is 20. And since 20 is less than 26, the inequality checks. The inequality check verifies that you have the correct inequality symbol, that it was supposed to be less than and not greater than. Here's an example where you're going to switch the inequality symbol. Begin the solution by subtracting 5 from both sides. Then divide both sides by -4 and switch the direction of the inequality. The solution is x less than -2. Because you switch the direction of the inequality, you can see the solution checks. Here's the inequality, its solution, and the graph of the solution, all the numbers less than -2. For the inequality check, select a convenient value in the solution set, like x equals -3. Then rewrite the inequality and substitute x equals -3. Next, -4 times -3 is +12, and 5 plus 12 is 17. Since 17 is greater than 13, the inequality checks. If you forget to switch the direction of the inequality, the solution would be x greater than -2, and it won't check. A convenient value greater than -2 is x equals -1. When you substitute x equals -1 into the inequality, you get -4 times -1 is +4, and 5 plus 4 is 9. Since 9 is not greater than 13, the solution doesn't check. So you can see why the inequality check is so important. So going back to the original solution, when you divide or multiply both sides of an inequality with a negative number, remember to switch the direction of the inequality symbol. And always graph and check the solution. This lesson showed how to solve inequalities. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.